Hi everyone, welcome to this hands-on tutorial. My name is Jane and I'm going to be your technical instructor today. We are going to build something incredibly powerful, a contamination-free multi-agent AI pipeline using a fantastic framework called Octochains. Now, if you've built AI pipelines before, you've probably used sequential chains where agent A passes its output to agent B, and so on. While that feels intuitive, in enterprise production systems, it introduces a major flaw: logical contamination and groupthink. If the first agent makes a subtle assumption or mistake, every single agent down the line inherits and amplifies that error. Octochains fixes this by enforcing a parallel, isolated reasoning paradigm. Today, we'll implement a mini-map reduce architecture. We'll broadcast a single input to multiple specialized agents, let them process it in completely parallel, isolated threads with zero awareness of their peers, and then use a centralized synthesizer to aggregate their clean, unbiased perspectives into an objective final verdict. Let's dive in. First, let's write a comment to mark our first step, which is installing Octochains and its dependencies. I'll add another comment here to remind us that Octochains is completely zero dependency, meaning we can use any LLM library we want. Now let's run a pip install command to install Octochains, the OpenAI SDK, and python.env to manage our environment variables. Let's see what this outputs. Now let's look at why this matters and how we actually connect our models. One of the best design choices of Octochains is that it is entirely model agnostic. You don't need to learn complex, heavy plugins or get locked into a specific ecosystem. In simple terms, what this means is that to interface with an LLM, you just write a standard Python function, called an LLM callable, that takes a prompt string and returns a response string. Let's start by setting up our environment variables and writing a clean, lightweight wrapper function using the official OpenAI SDK to get our engine ready. We'll start by importing OS, load.env to handle our keys, and the OpenAI client. Let's add a comment explaining that we are loading our environment variables from a local.env file. We'll write another quick comment to remind ourselves to set up the OpenAI API key in that file. And a quick example comment showing the exact format of the API key variable. Now, we call load.env to actually load those variables into our environment. Let's add a comment indicating that we are about to initialize our OpenAI client. We instantiate the OpenAI client here, which will automatically look for our API key. Next, let's write a comment explaining that we're defining the custom LLM callable wrapper that Octochains requires. We are calling this function call OpenAI. It takes a prompt string, sends it to the GPT-4o model with a temperature of 0.4, and returns the raw text response. Let's add a comment to set up a quick sanity check for our new wrapper function. We'll create a new variable here to store our results from a test call to our wrapper. Let's print out the test response to make sure everything is connected correctly. If we run this, we'll get our confirmation. With our LLM connection verified, let's define our isolated expert agents. To truly showcase why parallel isolation is such a game changer, we're going to design two opposing characters evaluating a new business pitch. First, we'll have the venture capitalist Optimist, who searches strictly for upside, scalability, and market disruption. Second, we'll have the critical risk auditor, a pragmatist searching strictly for operational pitfalls, liabilities, and failure points. If these agents worked sequentially, one would inevitably bias the other. But with Octochains, they will analyze the pitch in complete, blissful isolation, ensuring we get raw, unpolluted perspectives from both sides. To build our agents, let's first import the base agent class from Octochains. We'll add a comment noting that we need to subclass agent and implement its execute method. Here, we define specialist agent, overriding execute to build our prompt, and pass it directly to our LLM callable. Let's write a comment for our first agent, the optimistic venture capitalist. Now, we instantiate our Optimist agent, giving it a clear role, an optimistic goal, and our OpenAI callable. Let's add a comment for our second agent, the risk-focused pragmatist. We instantiate the pessimist agent, setting its role to critical risk auditor and giving it a goal focused entirely on finding flaws. Finally, let's print a confirmation message showing that both agents have been successfully initialized. Let's see what this outputs. Now that we have our specialist agents ready to go, we need a way to bring their insights together. Instead of letting them argue and influence each other's thinking, we introduce a neutral third party, the synthesizer. Think of this as our objective chief justice. It's a built-in aggregator in Octochains that takes the raw, unpolluted reports from both our Optimist and Pessimist, weighs their arguments, and crafts a balanced final verdict. This means we get the best of both worlds without any of the groupthink. Let's configure our aggregator with its specific goals and instructions so it knows exactly how to handle the conflicting perspectives it's about to receive. First, let's import the synthesizer class from the aggregators module in Octochains. We'll add a comment here to document that we are setting up instructions for our ultimate aggregator. Now let's define the aggregator goal variable. This prompt instructs the LLM to act as a neutral senior managing partner who evaluates the briefs objectively. Next, we'll add a comment indicating that we are about to instantiate our synthesizer. Let's create our Chief.Justice synthesizer instance, passing in our OpenAI callable and the custom goal we just defined. Finally, let's print a quick message to confirm everything is configured and ready. Let's run this to see the output. With our specialists and our aggregator configured, we are ready to bring the entire system to life. We are going to initialize the Octochains engine, passing in our array of agents and our Chief Justice synthesizer. When we trigger the run method, the engine handles all the complex multi-threading under the hood. This means that Octochains will spin up completely isolated worker threads, execute the prompts simultaneously, and automatically feed those clean, unpolluted logs directly into our aggregator once they resolve. Let's run the engine on a wild business pitch and watch the parallel reasoning in action. First, we need to import the engine class from Octochains. Let's add a comment to note that we are assembling our multi-agent pipeline architecture. Now, let's initialize our engine by passing in our list of specialist agents of the Optimist and the Pessimist, along with our synthesizer aggregator. We'll add a comment explaining that we are defining the raw input business pitch that our agents will analyze. Let's write out the business chart pitch string. This is a wild idea, delivering hot gourmet coffee via drones directly to office windows in New York. Let's print a status message to indicate that our parallel execution engine is starting up. We'll add a quick comment explaining that we are running the engine with logging enabled so we can watch the live execution. Finally, let's run the engine with our business pitch and store the output in a variable called report. Let's see what this outputs when we run it. Our engine has finished running, and now we get to inspect the results. Because Octochains preserves explicit execution traces, we can peek behind the curtain and look at the completely unpolluted raw thoughts of each individual specialist before they were combined. This means we have a perfect, audit-ready log of exactly how our optimists and pessimists arrived at their conclusions. This is massive for compliance, debugging, and transparency. Let's write a quick helper using Python's text wrapping to print out these raw logs cleanly so we can analyze them. To make our output look clean and readable in the terminal, let's import the standard text wrap library. We'll add a comment here to remind us that we are looping through each isolated agent's trace inside the generated report. Now let's write a loop to iterate over report.traces and print out each agent's role, their execution status, and a divider line. Inside the loop, we'll process the output line by line, stripping white space and skipping empty lines to keep the formatting neat. Finally, we'll use textwrap.wrap to limit our line width to 150 characters so it fits beautifully on our screen and print each wrapped line. Let's run this to inspect the raw, unpolluted thoughts of our agents. When you look at these raw outputs, you're seeing the pure, unadulterated thoughts of each specialist. The optimist didn't water down their enthusiasm because of the pessimist's worries, and the pessimist didn't hold back their warnings. This means we have a completely untainted audit trail. If you're building systems that need to comply with strict regulations like the EU AI Act, this level of traceability is absolute gold. You can prove exactly what information each agent had and how they reasoned through it, completely free of groupthink. Now that we know our experts worked in perfect isolation, how do we bring their insights back together? That's where our synthesizer comes in to deliver the final verdict. In production, we can't just rely on a messy block of text that we have to parse with rejects. Instead, Octochains returns a beautifully structured consensus object. It gives us a clean narrative summary, a list of actionable key takeaways, a self-assessed confidence score to act as a quality gate, and direct citations linking back to the original expert reports. This means your downstream systems can easily consume the data without breaking. First, let's import the text wrap module to help us format our final output beautifully. We'll add a quick comment here to indicate that we are formatting and wrapping the narrative executive summary. Let's print a clean header to mark the beginning of our executive summary narrative. Now let's extract the consensus narrative from our report, strip any extra white space, and split it into individual lines. All right, let's loop through each line, handle empty lines properly, wrap the text to a clean width of 100 characters, and print it out. Next, let's write a comment to show we are going to display the system evaluation metrics. Let's print a header for the system metrics section so it's easy to read. We are printing the self-assessed confidence score here, formatting it nicely as a percentage. Let's also display the total number of expert sources cited by our synthesizer. And finally, let's print the number of strategic takeaways extracted. Let's run this cell to see our final polished consensus report. And there you have it. We now have the complete, structured Octochains output right in front of us. This means you don't just get a final yes or no decision. You get a fully audited, high-confidence strategic brief. You can easily loop through the key takeaways to trigger automated workflows or flag decisions with low-confidence scores for human review. It's clean, reliable, and ready for enterprise production. Congratulations! You've officially mastered parallel reasoning with Octochains. In simple terms, what this means is you now know how to design and build contamination-free, multi-agent pipelines that are ready for enterprise production. Let's take a quick moment to look back at what we achieved today. First, we explored why sequential agent chains can lead to logical drift and groupthink. Then, we created a lightweight, model-agnostic LLM callable wrapper. After that, we spawned multi-threaded parallel agent operations using the engine. And finally, we used the synthesizer to cleanly merge contrasting perspectives into a structured, audit-ready verdict. You can now apply this map-reduce style architecture to your own complex AI workflows to ensure high reliability and compliance. Thank you so much for coding along with me today. If you found this tutorial helpful, please don't forget to start the Octochains repository on GitHub. Keep building, and I'll see you in the next session.